In the middle of the 1960s, the former musician John R. Wiegand, owing to his perfect pitch, discovers the special properties of a torsion wire, a magnetic iron alloy wire. His further measurements confirm he can produce a wire using a special process which creates an energy impulse through a sudden change in magnetism. On the 18th of April, 1978, John Wiegand applies for a patent to manufacture the Wiegand wire. 40 years later, SEW-Eurodrive acquire his original notes. Two engineers, Dr. Olaf Simon and Dennis Radel, evaluate the more than 40-year-old records. Their goal? A rotary counter with a Wiegand sensor, energy self-supplied, which functions on any electric motor or transmission.
For automation in factories with many movement processes, you need to ascertain exactly where a movement has begun and ended. And here we need an angle position encoder and counter which can measure the number of motor shaft revolutions. Without such an absolute encoder, a machine has to find again its original starting position after a power cut. To do this, it uses a creep gear, which is very time-consuming. Whereas with an absolute encoder, after switching on the machine again, it knows its exact starting position and can immediately go back into operation.
The most important part of the Wiegand sensor is the Wiegand wire. Both the cobalt iron vanadium alloy and the correct processing are decisive. It was immediately clear, in order to manufacture the wire with the best properties, it was necessary to do more materials research. At this point, Professor Jost and Miss Christian from Steinbeis Transfer Center for Materials Development and Testing in Pforzheim were asked to participate in this project.
SEW has been working with Wiegand wires and Wiegand sensors for a long time. Time and time again they noticed that there were considerable differences in quality between suppliers. These differences were so huge that no product could be brought to market. And so SEW contacted us for help.
For the first time, Ms. Plaskanka Weisenberger from the Steinbeis Center in Pforzheim managed to show the different magnetic zones of Wiegand wires. For this purpose, she laboriously prepared whole rows of material samples. She was thus able to produce the structural analyses necessary for optimization, with which, for example, the precise grain structure of the wire could be determined. The most suitable method turned out to be a combination of mechanical grinding and polishing, followed by ion beam etching. In other words, the finest removal of atoms from the surface. This, together with the follow-up examination with a field ion microscope, brought the best results. Using this special approach, it was possible for the Steinbeis Transfer Center to define precisely the effect of different thermomechanical treatments on the structure of the Wiegand wire. SEW-Eurodrive was then able to use this know-how in the production of their wires.
The quality of the wire originally bought fluctuated strongly, yielding between 0% to a maximum of 20%. We therefore started to tackle the wire quality. We now have a yield of around 95%.
The result? A wire which has at least 10 times better properties than the original wire. Wiegand's wire.
The number of intelligent motors is increasing continuously because we are striving to save energy. That is, to drive a motor only when movement is called for and only as long as it's needed. Sensors like this are then necessary. Today, 10% of standard motors are already equipped with sensors, and the trend is increasing sharply. We have verified the alloy combination essentially developed by John Wiegand. Okay, but now we can do further research into what differences an alloy combination might have and what optimization possibilities there are. And this gives us further potential for future developments.
John R. Wiegand spent his whole life looking for further applications for his wire. The transfer partners have now found an application and further optimized it. Mr. Wiegand would be really proud.